Okay. Any questions first from last week discussion? Do you still have do you still confused about the related rate? Have you tried to read some questions? Because I think some of the students asked me some problem from the related rates. So maybe I will go through the chapter 4 a little bit, and then maybe at the last 30 minutes, I will go discussing some related rates problem. Okay. So I will start with the extreme value theorem. Okay. So usually, if you read the textbook, usually you will see the extreme value and then mean value. Okay. But I decided to take the mean value first and then extreme value. So this will be uh, discussing about the maximum and minimum value from the graph. Okay. This we call the max, and this is the minimum. Okay. A typical maximum and minimum you already learned from maybe from junior high school. You already learned how to find this point. Okay. So let me write if the functions is continuous on interval a to b, and functions will or has both maximum and minimum on interval. Okay. Okay. We call this is maximum. We call this is minimum. Okay. If the function is only identified at AB, we call this is the absolute maximum. This is absolute minimum. Sometimes we call also global max, global mean. But I think absolute is mostly used in this extreme value. Okay. So maximum and minimum is not always like this typical curve, like in here and here. Not always like that. Maximum and minimum, it can be also at the end of the graph, okay? At the end interval. It's also maximum and minimum. Okay? So every time the point is the highest, we call maximum, the absolute maximum, and the lowest will be the minimum. Okay, okay, let me give you another graph illustrations. So you see here, there are at least 5 important points. So if we want to describe one by one, this should be the left one should be the lowest. Okay? And the right one should this one, and the right side, not the right interval. This is the highest. This is we call the absolute maximum. Okay, and this part and this part. Check. Okay, thank you. Okay, and this part, the local max and local min. Okay. This is we can also call local min here. Okay, so every time you have, for example, why we call maximum and minimum. Okay. Uh, it's not also about the highest and lowest. That's the absolute maximum and minimum. But maximum minimum, you see the change of the gradient. Okay, from here, okay, see the from the left to the endpoint, your gradient is changing, right? It's positive gradient, right? But after it goes through the local max, the point, okay, the gradient becomes negative, right? So when you have change in gradient from positive to negative, you can say that, okay, that's my maximum. Okay. And also from minimum, and then you change the gradient in the curve, you also get a positive here, and that's when you call the point minimum. Okay. And remember when we are discussing the runner, he runs forward and then backwards. Okay, imagine that as a gradient. So positive and then negative and then back to positive. Okay. So I hope you get the idea from here. And let me write some theorem. So if the function has local max or minimum at, let's say, at C, then the functions of C exist, and the first derivative at that C will be 0. Okay, this is important. This is what we call at the last week discussion is our critical point or number, or turning point. We can also call turning point or a stationary. So at the exact 0, f prime is our critical number. So if this is, for example, if this is A, this is B, the interval, and maybe here is C and D. Okay, so at this case, we can say that f prime C is 0 and f prime D also 0. Okay. The gradient is horizontal, meaning the gradient is 0. Okay. Okay. Um, so in the graph, okay, you need to see if you have a function, the function is having some interval, then you need just to observe the function on this interval. Okay. But if you are having a functions like general functions without specific interval, meaning you need to also consider the domain. Okay. So always consider domain. whenever the functions is, for example, you have 1 x minus 1. Okay, it can be undefined, right? It can be undefined. When x is equal 1, this is undefined. And what happens when the point is undefined? If it is a whole, then it's not continuous functions, right? But if it is like pointing like this is also undefined, right? But we say in the graph, this is still maximum because it's changing the gradient from positive to negative. Same idea, but the f prime is undefined. So aside from f prime is 0, f prime undefined also grouping in the same category as a turning point or critical number. Okay, this is also a critical number here. This is also critical or critical point, despite it is undefined. Okay, so you have f prime is 0 or f prime is undefined. It's also a critical point. Okay, so critical point is not necessary f prime equals 0. Okay, okay, let me give you some graph example. Okay, so here the first one. Okay, you see in the left is it's a whole. Okay, so the A and B is not included in the graph. If it is included, maybe it's absolute minimum, but because it's a whole, it's not absolute minimum. Okay, and then let's see if we have asymptote, we have some whole. Okay, this is also we can have. So you need to check the domain. Okay, check the domain, and also maybe checking the asymptote is also important. You can have the vertical like that, vertical asymptote, or horizontal, or line, any line that can make the asymptote. I will go through the line asymptote later. But let's identify this graph first. Okay, so you have the idea for maximum minimum. Okay, okay, we have x0, x1, x2, x3. Okay, let's naming all these points. Okay, so you have when x is x0, because I think it's the highest from this graph, we can conclude that this is the absolute maximum. Okay, and it is the f prime is 0. Okay, because you can have the horizontal gradient like that, right? And then x1, maybe it's not really clean, but it's actually, yeah, like that. This is also having the horizontal gradient, but because it's not the lowest, so I will write here local minimum. F prime x1 is also 0. Okay. Now we have the x2. It's the pointy. Okay. It has a pointy round thing. Okay. So this still we call local max. Okay. It's still a maximum point, but the f prime of the x2 is undefined. Okay. Okay. And in x3, okay, if you see the graph x3, this is also horizontal gradient, right? So the f prime of x3 is 0, but is it maximum or minimum? It's not both. Okay. So if you see here, it's from the left, it's the minus, right? But the right side, okay, here, the gradient is also minus because there is no change in gradient. It's still negative and then negative after the point. It's not maximum or minimum. We just say it's critical point, but it's not maximum and minimum. Okay. So I will write this as critical point, but not max, not min. Okay. Okay, let me write some definition from what we have observed from the graph. Okay. So let me write the theorem is C is let's say a critical number, meaning C is in the axis of f of x if and only if f prime C is 0 or f prime C is undefined. And when we have f prime x less than 0, meaning it's negative, the gradient is negative, meaning the function is decreasing, function decreasing. When f prime is greater than 0, the function is increasing. Okay, if we have example, maybe just hx, function h is negative x cubed plus 3x squared plus 9. If you want to find the critical point, because it's just a normal polynomial functions, we can just directly go to the h prime is negative 3x squared plus 6x. And this should be equal 0. And we can solve this, okay, easily, just factorizing the x. So x is 0 and 3x is 6, x is 2. Okay, when you get this point, okay, another method that you can try to check is using line number. Okay, this is quite handy. And checking all the point, okay, checking all the sign, okay, negative, positive. Okay, when you check the sign, this is negative, right? Negative 1, yeah, negative 2, yeah, it's also 3, yeah, it's also negative. This is positive. So this is decreasing, increasing, and also decreasing. So sometimes the question is asking when is the functions decreasing, and say from less than 0 it's decreasing, and after 2 also decreasing, and between 0 and 2 increasing. Sometimes you are writing this is going down, going up, going down. Yeah, but it's not necessary to draw this, but at least the signs is important. The signs is important. So let's try another example. So the functions is 12x negative x cubed. And I have the interval now. Find all extreme points. Okay, can you try? Can you try this one? Uh, Extreme point means when you have a value, either maximum, minimum, you need to describe whether that is maximum, minimum, local, or absolute. Okay. Maybe you directly derive, because I think the function is quite easy. It's just a polynomial. And then maybe you are equaling 0, and you get the 3x squared is 12, x squared is 4. You get plus minus 2, and then maybe you check the point, checking -2, checking +2. In between, you said that this is positive, and then when you have negative, equal negative, it's greater than 2, also negative. So it's decreasing, increasing, and decreasing, right? But when you have the questions, find all the extreme points, you need to have the points x and y. Okay, which one is the maximum? Which one is the minimum? Okay. Maybe you try to substitute the 2 to the functions. So f2 is 16. F -2 is what? -2, 16, also 16, but negative. Okay. But when you have this 2 points, okay, maybe from these points only, you will say that 16 will be maximum, -16 will be minimum. Okay. But remember, okay, always remember, when you have the interval, you have interval -3 to 5. Okay. You need also to check the interval. Okay. Check the interval. So check f -3. F -3 will be -927 and yeah 36. And F5 60, 60, 125, 65. It -65. Okay. Now you have -65, which is lower than -16, right? So this will be the absolute minimum. This is the absolute max. This is just a local max and local min. This local max, local min. And maybe probably the graph is yeah. So this is the absolute max. This is local mean. And this is the local max. And this is absolute mean. This is just roughly illustrated based on the numbers we get from the calculations. Okay. I will give you still polynomial functions, but let me um, give you another one. Let's say the function is x to the fourth. Okay, find critical point. Okay, let me give you two questions. The other one is, let's think about the absolute value, if you have absolute value. This is also a critical point. Okay, number one, what is the critical point? Can you solve this? No? Okay. You're thinking this one? Okay. 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 Only this, right? Only this. Okay. Okay. This one? Okay. Can you solve? No? Okay. Oh, by the way, how was your TA? Your teaching assistant? Is it? Did he give you homework? How many homework? How many questions? 50? 60? Did he tell you that you need to write all the questions, or only writing odd numbers? But the total should be how many? How many? The total should be 50. Okay. Did he give you like the typical these questions, or all most of, like, only this type of questions, or all? Do you think it's too much? Okay. Okay. I will talk to him. But how about the TA class? Did he teach you well or make some confusion? Did he teach you well, or you still having problem to understand what he say? Did you think? Do you think so? Okay, okay. Maybe I will take a look around when your TA is teaching. Okay. And maybe I will tell your TA about the homework. Okay. Okay. Number one. Okay. Um, it's more like not necessary when I say find critical point, then find the number that you can find. Okay. What does it mean? If you have this is f prime, if this is x, 4x cubed plus 3x squared plus 2x, okay, and it should be equal 0. Okay, maybe first thing you can do is just factorize. Okay. And the other thing is, remember that when you have the quadratic formula, a minus b, remember this? This part is called the determinant, okay, d. If this d part, okay, when you are seeing any negative number in below the square root, then you can just definitely go to say there is no real solutions. So the only way you can get the solution is just looking at this x. When x is 0, because it's finding critical point, then we find the f0 is 1. So 0 and 1 is our critical point. Or you can just say critical point when x is 0, that's also okay. You can also write there is no real solution because d is less than 0. D is p squared. Okay. I remember learning the d something, I think high school. Yeah. And how about the absolute value? The absolute value. Okay, remember, every time you have the absolute value, every time you have this, you need to check both cases. The positive one, and let's just write this is greater, and the other one is less. Okay, just let's say that one. So the x will be greater than 4/3. The x will be less than 4/3. Okay, and then maybe you want to derive. Okay, you want to derive the f prime. This can have absolute of 3, meaning you have 3 and negative 3. But again, you have the conditions where the x is related to 4/3. This is greater 4/3. This is less 4/3. Notice that when you derive, the equal signs, okay, the equal signs is removed. Okay, remember you have the, if you have absolute, at least like that, right? You have the pointy. Okay? When at that point it's undefined, right? So the functions you can write the functions. The f prime doesn't exist at the but you still can have this number, okay? But at the x 4/3, it's whole. Okay, let me give you one more. Uh, okay, find the extreme point and determine whether it's max, min. How many questions in homework until here? But the odd number, both number. Okay. So if you see the functions, okay, you can think the functions. Uh, if you have the gx, okay, let's say it's x cubed. Okay. If you move the graph to the right 1 point, it will be our fx, right? So basically, this is uh, the x cubed this x cube like this, but you are moving to the right side 1 point. Okay, so from this 0 you are moving to this one. Okay, when you see this graph, okay, this part the gradient is positive, right? And after 1 the gradient is also positive, right? So there is no minimum or maximum, but still this one is our critical point. Okay, so if I write completely, then f prime is 3 uh, x minus 1 squared. Okay, and it's equal 0. So x should be 1. So the critical point is 1, 0. This is critical point. Okay, again, the critical point is defined when f prime is 0, but not necessarily its max or minimum. Okay. And usually it's described in the odd functions like x cubed, x5. Let me give you one more, and then maybe we can uh, go back to the related rates and solve maybe 2, 3 problems from the related rates. Okay. Okay. Find extreme value from function determine okay, so you have the rational functions. And maybe if you already determine which one is maximum or minimum, maybe you can try to figure what is the graph look like. Okay. Uh, if you have any functions that is not really describing the interval, then you need to consider the domain. Okay. So consider domain, and also the asymptote that maybe the function has. So if you have the functions, uh, if you have limit as x approaching 1, this will be going to infinite, right? And also limit as x is -1. This is also having the the limit, right? It's going to positive infinity, both of this limit. So we have an asymptote. So we have a vertical asymptote at x equal 1 and x equal -1. Okay, and then we can look for f prime. And 2 x squared minus 1, -2, -2. Wait, let me write down the whole formula. So f prime will be -2, 2x, and then x squared minus 1. Or we can write this as -4x over x squared minus 1. Okay, and this is f prime. When f prime is 0, then the only thing that you can think now is this -4x, right? So x should be 0. That's the one x that we can find from the f prime. And then let's draw the line number. Okay, this is 0. But remember, we have -1 and 1 as our asymptote, right? So we need to think of this fraction. Okay, maybe you can think of -half and half. Okay, and you try to look at the original function. What will happen? Or maybe at the f prime, is it decreasing or increasing? If we have -half squared, it's 1/4. -1 is negative, right? Negative is positive, right? It's positive. It's increasing. Also in half, this half is also increasing. So maybe this graph will be increasing like that. But when you plug in zero, this zero here, let me draw this. When you plug in zero, it will be -2, right? So let me draw -2 here. This is -2. So maybe here, the graph is like this one. And you can try less than -1 and more than 1. It will be like that. So let me put the original graph. Let me look for the. Okay, this is the graph. So at the x0 is -2, but this -2 is max. Okay, so you can write the 0, -2 is our local max, because we couldn't determine the absolute one, right? Because it's going infinitely among at x and 1. Okay, any questions? After this part, I will go back to related rates to see some, maybe 2 or 3 problems and try to solve it. Okay, any questions? No? Okay. Yeah. What's your question? Okay. Okay. Good questions. Okay. Um, if I have functions, okay. Okay. Yeah. Is it make sense? Just yeah, just make it the, if this is the functions, okay. If it is functions, okay. How to use the, what's the difference in using the original function and the derivative, right? The questions. Okay. Okay. Let's take a look at our definitions. Okay. So f prime, okay, is basically our tangent, right? Or gradient. Okay. Okay. We can observe f prime from the original functions. Basically, we can observe from every point that we can see from the graph. Okay. For example, this point, and this point, and this point, and this point. Okay. We can see from the graph, okay, if f prime is greater than 0, meaning this is increasing, right? It's positive. It's increasing. Okay. So when f prime is greater than 0, the original functions. is increasing. So if you know the f prime situations, let's say you don't have this graph at all. Okay, you have the functions, and you can derive the function to f prime. When you see the f prime, see when the f prime is 0, that is your critical point, probably, right? And when your f prime, if you try to plug in some number, okay, to your f prime, when the f prime is greater than 0, the original function should be increasing. And when your f prime is less than 0, the original f should be decreasing, right? You don't need to really carefully graph all the functions. Maybe the function is too complicated. You just see what's happened with the f prime, okay? And then the f also, if you get the x, okay, from the f prime, okay, the critical point is x maybe equal 1. What is the point in the graph? That is when you are putting the x equal 1 to the original function. And you get, okay, that's the value of maximum or value of minimum if they have maximum and minimum, right? So the idea of the f prime is to see whether the function is increasing or decreasing. Even you don't really know what is happening in the graph, in all interval in the graph. Like, what is the functions really look like? You don't really need to know. You don't really need to, unless the question asking you to graph the function. Okay, but if it's just asking when the function is increasing, you just need to find the f prime and find when it is positive. And what is the critical point? You need to find just the f prime when the f prime is 0, when f prime is horizontal. Okay, okay, got it? Okay. After this, maybe next Friday, I will go, after this session will be the second derivative and how we are using the second derivative. Okay. But now let's back to the related rates. Okay. I think I forget this class or other class asking these questions. The mass of part of wire. Let me make it bigger. Okay. Can you see? Is my writing, can you see clearly, or is it really bad? My writing, is it really bad or not? So the mass of part of a wire is some functions, kilogram. So it's mass, okay, in kilogram. And x is measured in meters from one end of the wire. Find linear density of the wire when x is 4 meters. So actually, it's the functions of its mass. Okay, so the whole function is mass, okay? But the variables inside is involving x, right? That x is involving meters. So it's both including the meters, and the total functions will be in kilogram. Okay? But you need to have some basic in physics, okay, to understand the questions. Okay. Okay. The idea is, so imagine the wire. Okay. It's really long, right? Imagine really long. The wire is actually like a cylinder. It's like a tube, right? But because the ratio, okay, this length and the radius is large, okay? So you can think any radius here like a dx, like a really, really small. And then you need to go from the not P, sorry, should be the density. Okay. Basically, the density, the regular density is what? Mass over volume, right? Volume, right? Okay. But how do we get the idea of mass and volume, especially when you have the function is in kilogram? Okay. Oh, here's the thing. Okay? Before I go through some physics and solving this problem, uh, always think that most of related rates problem, or I think all the problems in your textbook, you will have the relations. You derive that relation. Okay. So basically, it should be concluded as a simple relation, not really that complicated and using like several physics phenomena to solve this. Okay. So you need to simplify things that you can simplify. You need to simplify. Okay. So we need to think, okay, linear density, okay. So we need to find density from that function. Okay. Okay. So if this is x, okay, if this is x, and the mass is x, what is density? It's mass over volume. So every part of mass divided by your volume. Okay, but it is only linear density. So you need to only consider only one axis. You don't really need to consider the volume. So you can simplify these things and make this the linear density. Let me write linear density as d density is dm over dx. Okay, so dm over dx, I can get this from uh, it's 1 plus squared x plus x 1. Okay, this is my linear density. Okay, so simplify things, okay, from physics. Okay, and then when x is equal 4, so 1 plus square root of 4 plus 4. So this is canceling each other. 1 plus 2, it's 3 plus 1 is 4. It should be kilogram over meter. Okay. So usually related rates, it's not really that complicated. Okay. You need to simplify things, and then when you find the relations, what you need to do is just derive the relations. Okay, this is also a typical problem in most of related rates questions. So you have street light, like you see in the street, like a ball, right? So it's illuminating the light, and then you see one man, okay, it's walking, and when he walks, of course, you will see this shadow, right? And then the question is asking how fast is the tip of his shadow moving when he's 10 meters. So when he moves and the x is changing, the distance is changing, the shadow is moving, right? So it's asking uh, what is the rate of change of the shadow. To understand the questions, you need at least drawing the diagram. What will happen and how you are relating the problem with some. I think this is you need to use some simple geometry from this one. Okay, let me draw the what is happening. So you have the, let's say this is the straight line. Okay, there's a man. This is 6 meter. 6 meter. This is 2 meters. And it has at least you can see the shadow. Yeah, at least this is how it looks like. Okay. The man is moving some speed. I think speed is 1.5 meters per second. Yeah. Sorry. Can anyone solve it? Anyone solve? Can you solve? Which one? Solve this one. Oh, okay. Okay. To solve this, you need to see the relation between, let's say this is the pole, this is 6, and maybe this is the man. The man is 2. Um, let's say this is x and this is y. The base of the triangle, um, y over 2 is equal x plus y over 6. From here, we can solve and get the relation between y and half x. We get these relations. And actually, what we need to find is the man is moving away from this straight line, right? And he's moving, right? So we need to calculate x and y, right? From the first time he moved away from the straight line. So x plus y is our distance. We need to find our derivative from this distance. Okay? And we already have relations from the triangle for x and y. So the half x can go here, and I will have the dt is 3 over 2x, right? So this is 3 over 2 and dx dt, right? 3 over 2, dx dt is 1.5. So it's around 9 of 4. So the shadow, or the tip of shadow, speed is 9 over 4. You don't even need the distance when he is 10 meters. Don't really need that. You can also include that, but the ratio will be still 9 over 4. Maybe you can see this clearly. Yeah. So the rate is actually whatever distance the person will be, it's always 9/4. Okay. The question is just added the x 10 meters, but it's actually not really that impactful to the whole equations. Right? Okay. Any questions? Does it make sense to you? Okay, makes sense. Okay. Okay. Any questions? Questions? If I put something like this in the quiz, you can do it, right? Can do it or no? At least the easy one, you can do it, right? The easy one. Okay, let me give you another example. Okay, let me give you this one. Okay, a Ferris wheel. Okay, Ferris wheel with the radius of 10 meters. It's rotating. Okay, at a rate of 1 revolution every 2 minutes. You need to calculate with radians. Okay, the radians. How fast is a rider rising? Okay, when his seat is 16 meters above ground level. Do you know Ferris wheel? It's like a let me show you what is Ferris wheel. Okay, and this is moving. Have you ride this before? I ride one in the I forgot, but it's in south of Nanto. There's one big theme park. I ride this one, but I think the rail and the chains is a little bit loose, so it's like it's like shaking. So I'm just when I see the other people they are taking photo, I just sitting there like this. I cannot get up. Okay, so Ferris wheel it's like this. Uh, you have the rotations. Okay, it's asking how fast is the rider rising. So meaning at some point this what to say this cart is rising up, and when this is at 16 meters, okay, you need to calculate the rate of change, okay, the velocity, okay, the speed. Okay. Of course, to solve this, you need to maybe you just use the circle. Okay. You have the radians um, for the whole rotations of the circle. You have that 1 revolutions 2 minutes. 1 revolution is 3060 degree, right? 360 degree. So it's 2 pi. So 2 pi over 2. So it's just pi radian per minute, the total circle. Okay. But the question is asking just this part, okay, this small part of the cart. So if I'm simplifying this into a big circle, moving to the right. Okay. So imagine this is the whole first wheel. Okay. This is the ground. So the radius, it will be from the middle. This is the radius. So the rising, I will put rising as this. Okay. So this is the cart here. It will have some theta here. Okay. It still has the R. And this is the 16. This is 16. This is R equaling 10. Okay. Let's say I have 8 here. So the question is asking this H, okay? Or maybe you want to define the height from here. The height is also okay. But the question is asking the how fast is this H changing? Okay. You can try from H here or here, will be the same conclusion. Will be the same conclusion. Because at least you need to include the radius 10 and the ground level is 16. And you need to solve based also on this triangle. Let's say this is x. Okay. Of course, if you have this is 16, if this is 10, this is 6, right? 10, 6, maybe this is 8. 8, 2, but that won't solve the problem. So you need to make the number still in ambiguous position because it is changing, right? So the idea maybe you find the relations from the theta here. Maybe you get some trigonometric functions from these relations. You need to relate. You need h, right? So you need h, and you have 10. H 10. At least you have sine, right? Sine theta is h over 10. Okay, and try to differentiate that functions because you have h, you will get dh over dt, right? So let's just write the sine theta is h over 10. Let's just derive these equations. Derived with the dt, and you will get sine, it will be cos theta d theta dt, okay, and then h will be 1 over 10 dh dt, right? Okay, so d theta dt we get from this one revolution of every 2 minutes, okay? So d theta dt is 2 pi over 2, or this is pi radian per minutes. So d theta dt is pi And cos theta, what is cos theta? Let me write cos theta. Like I told you, if that's 6, then the other will be 8, right? So if this is 10 theta, this is 6, this is 8, right? So cos theta is 8 over 10. So when the h is 6, cos theta is 8 over 10, 8 over 10. D theta dt will be pi. This is 1 over 10. And d theta dt. And this 10 is canceling. So your dh over dt will be 8 pi meter per minute. Okay. So you need to find this age. Okay, this age. So from the problem set, from the questions, you need to have a conclusion that what is the rider rising mean? How fast rider rising? So riders, it means the person who are in the cart when he's rising above some angle. Okay, you define this as h or this whole as h. So you need to find this derivative, okay, the rate of change of this height. Okay, you find these relations. When you need to plug in the information, plug in all from the first one is the radian per minute. You get it from the questions. The second one, to find the cos theta, you need to make sure the theta when it's 16, it's 6 here, and 6, 10 is 8. So cos theta is 8, 10, right? 8 over 10. So this is cos theta. So cos theta is 8 over 10. This is just pi. It's equal this 1 over 10 dh dt. And the question is asking this dh dt, okay? The rate of change of the height, actually. Okay? So it's 8 pi meter per minute. It will be the same thing if you're making your age is 16, okay? Because you will also include this radius. It will be minus 10, and it's still 6. Still same conclusions. Okay, so in related rates, usually having a geometry, um, like a circular movement, radians, okay, radians. What else? The change in area, the change in volume. Yeah, now you have the angle also. But the idea is still the same. You have relations here. Find the relations that include your required questions. So it's required to find this h, right? This the h over dt. You get the relations from this triangle derived based on time, and you get these expressions, and you need to find the rest of the unknown variables from the information. Okay. Okay. Any questions? I think I will stop here. And okay. Also, uh, is there anything that you want to say about your TA? What you need, like maybe you have a suggestions. Okay. First, I already get your whole idea your homework, right? Is there anything else? Anything else? You can talk freely. You can talk freely. Too much homework? Too much? Too much, right? Yeah, you can just say it. Too much. Too much. Too much. Yeah. Okay. And then anything else? How he's teaching? Not clear? Not clear? Not clear? Or clear? Clear. Clear. Okay. Is it true? Is it true? Clear? Okay. Okay. Don't be nervous or shy. Okay. About. Okay. See you next Friday.